In this video, we're going to look at a very difficult A-star level question that combines the normal distribution with the binomial distribution actually. So it tells you that the chocolate bars whose weights, so I'm going to call the variable W for this whole question. So the weights W is normally distributed with the mean of 120 and the standard deviation of 6, meaning the inside of this would be the standard deviation squared, that is. Bars which weigh more than 114 grams are sold at this much profit. The remaining bars are sold at no profit. Show that the expected profit is supposed to be this much. So what we first need to do is find the probability of a bar, just one chocolate bar, weighing more than 114 grams. After we get that probability, we can multiply it onto 15p to tell you the profit that you could look at for each individual bar. So how do we find something like this? Well, you can just use the normal CD function on your calculator. Now, there's two different options for this. My calculator has the option where I can substitute in lower, upper, the mean and the standard deviation. So the lower in this case would be 114. You don't need to worry about adding 1 because and putting 115 as your upper, because this is continuous data, meaning it includes all the data in between 114 and 115, like 114.1, etc. So you can just take 114 as your lower. The upper, I just tend to put a very, very large number, something like 4 nines. The mean is 120 and the standard deviation is 6. Now that in your calculator, using the normal CD function, it spits out a value of 0.8413. Now, otherwise, your calculator might have the following that it says. It might just say X instead of lower and upper. In that case, you have to put this into a format of less than or equal to. In this case, greater than 14 is the same as 1 minus the probability of it being less than or equal to 114. So you can put X as 114, mu as 120 and standard deviation as 6, and you'll get that same value when you do one take away that value that you get. Great. Now that we got the probability of each bar being bigger than 114 grams, what's the profit of that one bar? Well, you can multiply the probability of 0.8413 by the individual profit, 15p, and that gets you 12.6195p. Okay, now that we've got the profit from each individual bar, it's asking you to find the expected profit from 100 bars. So what we expect to be from 100 bars is 100 multiplied by what we expect from each individual bar, which is 12.6195. This is the binomial part of the question because in binomial distribution we use NP to find the expected probability. And the probability of it being, I'm not going to go too much in depth about that actually, that's a whole different topic. That equals 1261.95p, which you just divide by 100 to turn it into pounds. So that's £12.62 to 2 decimal places. Of course, currency in pounds should be to 2 decimal places, like it says in part I. Now on to part 2 of the question, which itself is quite difficult. Let's break this down. So it subsequently decided that bars which weigh more than X, so more than X should be sold at a profit of 20p. So straight off the bat, I'm going to form an equation. I'm going to say that actually before I do, it says those that weigh X or less are sold at a profit of 3p. The expected profit for 100 bars is 19.17. Find the value of X. So what we know is that 20 times, let's break this down. So the probability of a bar being more than X, you multiply that to 0.2 because that's the amount of profit that you'll get in pounds for each of those bars. You then add on to that 0.03 multiplied by the probability of the weight being less than or equal to X, because 3p is the profit that you'll get from each of these bars. And all of that, well, what is that equal to? Actually, even before you go into what that's equal to, it says that this gives the probability of, or the expected profit, of one specific bar. Expected profit of one bar. Because you took 20p and you multiplied it by the probability that a bar is more than X, and then you took 3p and you multiply that, the probability is less than or equal to x. So combined will give you the profit of 1 bar. But here it tells you the profit of 100 bars. So how can we use the equation that we formed above to find the profit of 100 bars? Well, actually, we multiply each of these by 100. So 100 times this is, well, 0.2 times 100 is 20. So 20 multiplied by the probability of the weight being larger than x plus, well, 100 times 0.03 is 3. Lots of the probability being less than or equal to x. All of that is equal to the expected profit of 100 bars now, which is giving you the value of 19.17. Now we're almost at a position where we can find the value of x, but the thing is we need the probabilities to be the same. We need them to match. We can use the idea that the probability of w being greater than x is the same as 1 minus the probability of it being less than or equal to x. The reason I chose to make them both less than or equal to is it allows you to make it easier to use the normal CD function. So this is going to be 20 multiplied by probability of weight being bigger than x, which is 20 multiplied by all of this. So that's 20 minus 20 probability of the weight being less than or equal to x. If you add on to that 3 probability of weight being less than or equal to x, you'll get minus 17 of this. So you have 20 minus 17 probability of weight being less than or equal to x is equal to 19.17. Now we rearrange to make this the subject of the formula. So we take away 20 from both sides and divide both sides by minus 17 to get that the probability that w is less than or equal to x is actually just equal to 0.04882. Okay, how do we find x from here? Well, you can use the inverse normal function because we know the area that's covered in our normal distribution curve. What I mean by that is we know that the mean, 50% of the data is less than the mean, and here our probability of x is going to be way to the left because this area here is 0.04882. So in our inverse normal function, we put our area as that probability that we found, 0.04882. We use our mean that we sort of introduced beforehand, 120, and the standard deviation of 6. After you've done that, you'll get out the z value. Now the z value in this case is minus 1.657. Now what do we know about z values in general? They're equal to x minus mu over standard deviation. And they tell you how many standard deviations away from the mean the x value actually is. We're trying to find that x value, and we know the mean is 120, we know the standard deviation is 6, and now we know the z value because we've used the inverse normal function and the area to find it. So in our case, we say minus 1.657 is equal to x, take away 120, all divided by 6, multiply both sides by 6, and then add 120 to both sides. So we get minus 1.657 multiplied by 6, all plus 120 is equal to x, which in this case is equal to 110. And that's your final answer to this very difficult A-star level question. Hopefully that all made sense, and if you'd like me to go through more A-star questions like this, just let me know in the comments. Otherwise, be sure to like the video and subscribe if it helped.